Hello everyone. Today we're going to be tackling a limit that was present on the Stanford University 2018 Mathematical Olympiad. We are going to evaluate the limit as n approaches infinity of n squared times the integral from 0 to 1 over n of x to the 2018 x plus 1 with respect to x. Of course, you should pause the video and attempt the problem before seeing the solution. All right, so I'm assuming that you have tried the problem, and although there are a variety of methods you could have used to approach this, we are going to be using L'Hopital's rule today. So if you don't see the connection to L'Hopital's rule, consider the following. What makes this problem challenging is the presence of an integral. And as we know by the fundamental theorem of calculus, if we differentiate the integral, we will get the integrand. Therefore, we should search for a way to get rid of the integral by differentiating this expression. Now, obviously, we can't just differentiate what we're taking the limit of and say that it equals our original limit. However, if the expression is in this form, we can see immediately that we're dealing with an indeterminate form. Because as n approaches infinity, we're taking the integral from 0 to 0 of some expression dx, which is of course 0, divided by the limit as n approaches infinity of 1 over n squared, which is 0. So we have 0 over 0. So now we can apply L'Hopital's rule. And this is what we arrive at. So we are now considering the limit as n approaches infinity of 1 over n to the power of 2018 over n plus 1 times negative 1 over n squared, all divided by negative 2 over n cubed. And although this expression may be messy, we're no longer dealing with an integral within our limit. So this is a much more manageable problem. Okay, so after some elementary algebraic operations, we arrive at the following limit. And I apologize for the poor handwriting. This is supposed to be a power. We're not multiplying these two. And this is, once again, an indeterminate form. And in order to mend this, we're going to exponentiate and then immediately apply a logarithm in order to apply some of our familiar log rules and simplify the problem. And after exponentiating and applying some basic logarithm rules, we arrive at this limit, which is much easier to work with because if you observe that the natural log of 1 over n is the same thing as negative natural log of n, we can factor the expression at the top and the ones will cancel out. 1/2 times the limit as n approaches infinity of e to the negative 2018 over n times the natural log of n. Now, for our final step, we can either apply L'Hopital's rule once again, or we can simply observe that the natural log of n grows at a rate much slower than n. Therefore, this must approach 0. So our final answer is 1/2 times e to the 0, or 1/2. And we are done.